So, first problem. Cotangent theta plus 1 over cotangent theta. What could I do in the options? Anything stand out? Okay, let's start there. So instead of cotangent theta, let's write cosine theta over sine theta. It's cosine over sine.
Cosine. I guess. I have no clue erasing this thing.
There's a little eraser up at the top. Yep. And then click the, there you go.
Black just because I'm not. And it's a cotangent, so.
Okay, plus. Let's think about the other one. 1 over cotangent. What's the reciprocal of cotangent? Tangent. If I write that in terms of sines and cosines, then tangent is sine over cosine. So plus sine theta over cosine theta.
Plus sine theta over cosine theta?
Because the reciprocal of that is tangent, which is sine over cosine. Alright. So we're doing some of these problems together today because we're talking about some new strategies. If I want to add or subtract fractions, what do we have to have?
The same denominator.
Okay, this first one is sine. What does it need to match the other one?
Cosine.
So you will multiply by cosine on top and bottom. This one has cosine, so it needs sine on top and bottom. Alright, go ahead and write what we get after we do that. So cosine times cosine will give us cosine squared theta over, and you'll just keep it as sine theta times cosine theta on the bottom. Okay, plus sine theta times sine theta sine squared theta over sine theta cosine theta. So this is a technique that we are going to be using, getting the common denominator. So now the denominator is the same. Why don't you write those as one big fraction for us?
One.
Like
okay.
Cosine squared theta plus sine squared theta all over.
Okay. For some reason I always think you're gonna ask a trick question. And so it'll be cosine squared
theta,
and is it plus? Or is it just
plus?
Okay.
So you add the tops together and the denominator stays the same. Alright. Anybody recognize an identity here?
We can simplify it.
Yeah. Cosine squared plus sine squared is 1. So we have 1 over sine theta cosine theta. One last step we can do. This is a technique that we have not used before. Since all of this is one term on the bottom, that's the same thing as saying 1 over sine times 1 over cosine. You guys agree with that? What is 1 over sine? The reciprocal of sine is?
Secant.
Cosecant. And the reciprocal of cosine?
Secant.
So our final answer, this thing turned into cosecant theta times secant theta. So Josh, just on number 1, say you did it on the board on your paper. You don't have to rewrite it. Okay, that was a fun one.
I felt like I did a lot.
That one was a lot of work. Let's do number 3. I'll give you the honor of coming up for us. Maybe I should let the person that sits down choose the next one.
So I was just gonna start volunteering people if no one shows anything.
Alright, is there any obvious formula that jumps out here?
You said that.
We have cosecant and cotangent, but the formula we have involving those requires them to be squared. So, if you don't have a formula, go to sines and cosines. What can we change tangent to?
Sine.
So that's sine x over cosine x. Okay, times, so parenthesis, what would we change our cotangent to?
Cosine.
Cosine x over sine x. And what about cosecant?
1 over sine.
Now let's distribute. So we have to take this to both of them. If you multiply sine over cosine times cosine over sine, what do you get? 1, because they're reciprocals. So we have 1 plus.
Since the parentheses both have the same denominator, can we just add them first?
You could have, yes. Yep, and then cancel a sign off top and bottom, absolutely. When I multiply these two, the signs drop, so you're left with?
1 over cosine.
One more step. What is 1 over cosine x?
Secant.
So we have 1 plus secant x. Okay, and is that an identity? No. So you're done. That wasn't too painful. Alright. Let's do Montana number 5. Okay. What's 1 over cosecant squared? Reciprocal cosecant is?
Sine.
So it's a sine squared theta?
Just, it's not over anything.
Plus, what's the reciprocal of secant?
Secant.
Cosine.
I mean, yeah.
That has to be the most common error.
It is extremely common. What's sine squared theta plus cosine squared theta? 1. And you're done. Thank you. Alright. Sierra, let's do number 9. Alright. What are your thoughts? Anybody can pipe up. What would we do first?
Distribute.
We need that first 1 plus sine t squared. That you have to think about writing it twice and foiling.
Is that a thing?
It's a t. Okay, so if we FOIL that, we get 1 plus t and plus sine t,
So that'd be
2 sine t.
sine squared t.
Mm-hmm. And we still have that plus cosine squared t at the end. Sorry, my pen got too close to my board. Recognize anything?
It's sine squared t plus the cosine squared t.
Mm-hmm. We could turn that into a 1 plus our other one would give us 2 plus 2 sine t. Alright, good. We could leave it like this, but in a couple examples we're going to start talking about factoring with these. If I wanted to factor, what would you take out?
2.
A 2, and that would just leave you with 1 plus sine t. So we'll be using that technique later. Thank you. Alright, Gus, you get number 11. So, if I want to add or subtract fractions, what do we need?
Common denominator.
Mm-hmm. Well, you have to take the first one times.
1 minus cosine x.
Yep.
So because those are the opposite sign, can't I?
Do first and last.
Yeah, just first.
Yeah.
Minus cosine squared x.
Mm-hmm. Okay. So one thing here. What he's doing is getting a common denominator. So he's taking this times 1 minus cosine x. But you have to do it on both
Oh, yeah.
top and bottom. So the top will be 1 minus cosine x. Okay. Minus in the middle. And then what are we taking the second fraction times?
1 plus cosine.
Mm-hmm. Alright. We want to put those together. What should we do with the minus in the middle? Distribute through the top of the second fraction. So we'll make that a plus, and then it'll be a -1 and a negative cosine. So now when you put those together, what happens to the ones?
Go 0.
Those go to 0, so they're gone. Negative cosine x and negative cosine x would be negative 2 cosine x. Over 1 minus cosine squared, what is that?
Let's see. Sine.
Sine squared. Sine squared x. Okay. Last. Mm-hmm.
When you distribute, are you making the top and the bottom?
Just the top.
Oh.
And take negative to one or the other. One final step we're going to do. It's something we have not done before. Sine squared is like a sine times a sine, right? So if I looked at this, we have a -2. Cosine over sine is tangent x. And then this is just like a 1 over sine, which is so we could even write that one using cosecant and cotangent. Thank you. You got an uglier one. Alright. Moving on. We're going to keep doing a few more together. I want to look at problem 13. Okay, this section, our directions are to factor. So I just want to make sure we are comfortable with how these things would factor. Sine squared and 1, those are both perfect squares. So think about if I told you to factor x squared minus 9, how do you do that?
X plus 3x minus 3.
So if I asked you to factor sine squared minus 1, sine squared would break into sine theta. 1's positive, 1's negative, and 1 and 1. Sine theta plus 1, sine theta minus 1. So we can use those same techniques that we did in algebra. If we looked at problem 17. And I told you to factor that one. What would you do? Yes. Root 2 sine squared x and a 1. So these multiply to 2 and add to 3. What would that be? 2 and 1. And each of those gets a sign with them. So then we factor each column and row. So this would be a 2 sine x. This is a 1. This direction we get a sine x and a 1.
I didn't sign up for this.
It's a bonus, added bonus. Okay. I would like to switch gears for a minute. Let's do a couple examples in our notes. So the next piece, we are going to start proving trig identities. So this is section 2 now, proving trig identities. A proof is going to be extremely similar to what we have been doing, except you have the final answer given to you in the problem. So basically, I am going to tell you what it equals. You have to prove that to me. You have to show me why that's true. So you absolutely have to show all of your steps here. That is the answer, just that work. So for example, I want to verify or prove secant of t times sine t plus cosine t equals 1 plus tangent t. Our strategy. We don't want to just like treat this like a regular equation. What we will do is box in one side, and that is our goal, what we're working towards. I usually take the easier looking side. So which of these looks nicer? 1 plus tangent t. So I'm going to put a box around it, and I'm not going to touch that. Then I'm going to do this side like all these other problems we have been doing. And when I get 1 plus tangent t, I know I'm done. So what would you change secant t to? Good. Sine t plus cosine t, there's really not much to do there. If you distribute 1 over cosine times sine would become sine t over cosine t. One over cosine times cosine is 1. What is sine t over cosine t? Is tangent t plus 1 the same as 1 plus tangent t? Yes. So what I like is if you would box in when you get to your final answer. So every problem you do should have 2 boxes. 1 on the original equation, 1 on your answer, and those things should match. You can't just skip all the steps and write the final answer because you know what the answer has to be. So you have to show me all the logical steps in between. That's where your points come from. That's the proof piece of it.
So I'm assuming each one of these problems are going to equal that.
Yes, there is.
You're grading us on our work here.
Exactly. All of them do work out. I'm not giving you a problem that isn't true. So they all will work. You just have to show me how. So if I look at this, which side would you box in? Secant squared theta, that definitely looks easier. So on the left, you have options. What do you want to do? Okay. Tangent squared plus 1 is equal to secant squared theta. Let's go to sines and cosines now. Cotangent would be cosine squared theta over sine squared theta. Secant would be
So you can use that even if they're squared.
yes. The reciprocal and the quotient identities, they can be with any power. So then what happens? We don't need one, we're multiplying. Yeah, if you're multiplying, anything on top and bottom cancels, so we're left with 1 over sine squared theta, and 1 over sine squared is the reciprocal sine cosecant squared theta, which is what we wanted. We're done. I want to stop here and give you guys time to work and ask questions. So all of your homework is a proof. So those are just like the problems that we were doing before, except you know what the answer is. So please write out the original problem and box in one side so I know what you're working towards. That's your goal. And then you only touch the other side to get there. So on that same page that we've been doing problems on, page 202, I want you guys to do 35 through 41 odd, 51, 55, 57, and 61. So that's 8 problems, and you've got about 15 minutes right now to start those. us to